It's continuing on from yesterday. We're working on this example. We missed the fact that in the textbook they had diagrams with extra bits of information. So I'm going to draw the extra bits of information, and then we're going to look at the diagram that we have and see if we can solve it. Now that we added in the angle, and when we added the angle, north, west, north 30 degrees west, north 50 degrees east, we got this total angle in here to be 80, right? Now in your textbook, they have this distance here to be 9 kilometers, and they have the distance from A to B as 12 kilometers. And they want to know, what do they want to know? They want to know the compass direction, right? So they want north so many degrees, whatever, right? Now, in the textbook, and so we're going to have to erase some of our diagram here. In the textbook, the diagram looks slightly different, and they actually gave the diagram. So we better draw the diagram properly. A is higher than B, but this is still 12 kilometers here. Okay. 122. So, what's the only thing you can solve in sine law right now when we look at this? How do we know what we can solve for sine law? We can solve for angle B. How do you know we can solve for angle B? Because we know the side length, little b, and we have the angle directly across from this side length, right? So we have a side length and an angle on the same kind of cross quarter, or the same side, same angle, and then we have a known side with across from it an unknown angle. So we can solve for angle B, right? I'm going to give you 2 minutes to solve for angle B by yourselves. Okay? Solve for angle B. Round to the nearest angle you can. Is this how you guys set it up here? 12 over the sine of 80 is equal to 9 over the sine of B. So you cross multiplied, you got 9 times the sine of 80 is equal to 12 times the sine of B. You divided by 12, and then you took the inverse sine. I'm not going to show you this, all the steps, but you can do that, right? We've done this over and over again. What did we get? 47 point. Okay, so we get angle B to be 47.6 degrees, or roughly around 48. Okay. Now, does this make sense to you that it's 48? To me, it makes sense because the side length 9 is smaller than the side length 12, right? And so your angle measures should be the same kind of constitutional size. So this is side length 12, so the angle should be bigger than the one that has a side length 9. Okay? Now, we get to go back into the diagram because it did not ask for the angle there. It asked for the direction, right? So we need the direction when he leaves Lighthouse B. So on Lighthouse B, to get a direction, I need a north, south, east, west line, okay? Now what do you know, and this is where I was getting at yesterday already. This east-west line is parallel to this east-west line, okay? So what does that mean? We're bringing back Unit 2. That's what it means. What do you know about parallel lines? What is the one thing I tell you? Look for alternate interior angles, or use some of those definitions. So I have this line right here that's coming here. I know this angle here is 50, so that means this angle here is 50. This angle from the south line to that transversal is 50. That's using the north-south as your parallels. What else do we know? Can you solve for this angle here? This is 40. Why? Because between the north and the east-west line, it's 90 degrees, right? They make 90-degree quadrants. So if this angle is 50, this angle has to be 40, which means this angle right here, this one, to be 40. Do you agree? So what's this extra little angle up here? 8. The rest of the 48. Okay? So sometimes when you have to find directions, you have to break it and draw your north, south, east, west lines again. Okay? Now, it wants to know the direction it's heading to Lighthouse A. Right? Have you ever heard anyone go, I went west-south? No. I went east-north? No, I went northeast. I went southwest, right? Don't ask me why I put that hillbilly accent in the east-north and stuff like that. I don't know, okay? But what happens, you guys, is you always start either at the north or at the south, whichever one you're closest to. So this line right here that we're drawing, is it closer to the north or is it closer to the south? Closer to the north, right? So when I give my direction, when I give my answer, I'm going to say north, so many degrees, what? West. Never eat shredded wheat, right? West. Okay, so I'm going northwest. Now, how do I know what I'm putting in between there? So I know that I'm going north, so many degrees, west. This is my final answer. So this is my answer. How do I know how many degrees west I'm heading? Let's go back to our diagram. I know above this west line I have 8 degrees already. How far does it take me to get to the north from west? 90 degrees, right? 90 degrees from west to north. If I already have 8, what's left over? 82. Because 82 plus 8 gives me 90. So whenever we do this, to give your direction, you always look, am I closer to north? Am I closer to south? Then you figure out how many degrees you're going the other direction. Okay? So our answer is north, 82 degrees west. Is this okay? Then you could say just northwest, because 45 is directly in the middle. So when someone says northwest and you're actually like geocaching and stuff, you guys know what geocaching is? You're actually, if someone says northwest, that actually means north, 45 degrees west. Okay? So this stuff actually comes into play in real life some places, okay? Are we good with this? We're going to have 2 questions on our assignment that deal with this stuff. This stuff is stuff, this kind of question are the ones people struggle with, so take your time and really think about how you're drawing it. And some of the things are, what angle are they telling me? Okay, if this is to a side length of 10 and this is a side length of 5, well, it's going to be a shorter length, right? So it's going to be a shorter angle on that side as well. So you've got to really think about how your triangles are being drawn. One more example. Ready? A radio mast is supported by 2 wires on opposite sides. So we're making an assumption that the opposite sides are 180 degrees. Okay? On the ground, the end of the wire are 60 meters apart from each other. One wire makes a 62-degree angle with the ground, and the other one makes a 75-degree angle with the ground. To the nearest tenth of a meter, how long are the wires, and how tall is that mast? I want to give you a couple minutes to draw this diagram yourself. Just want to see where you're going. So I'm gonna leave us for 2 minutes for you to draw this diagram yourself. Are you guys ready? I was walking around and I saw lots of good things. Okay? So what I normally do is I draw the ground, and then this said a mast, which is just a big tower pole. You have to make an assumption that the guy that actually put this mast or pole in actually put it in a 90-degree kind of thing. Okay? I know sometimes things are leaning, but we're living in kind of a perfect mathematical world. He put it straight 90 degrees up. Okay? He has wires that go from the top of the mast down to the bottom. Okay? So if this one's 62 degrees here, I expect that side length to be smaller than the one that's 75-degree angle, right? So the one with the 75-degree angle here, this is going to be a longer side. How do I make shorter sides? I draw closer, right? So this is the shorter side length. This will be the 75-degree angle. So it should have looked something like that. The last thing I needed to add was the last bit of information they gave us in the question, that this entire length from here all the way to that corner there, that's 60 meters. Okay. How are we doing? People got a pretty close diagram there? What can we solve in this question, you guys? We need to know the length of the wires. Okay, good. So what Jesse is saying, the first thing you need to do is solve for this top angle, this big top angle from here to here. That's the only thing we can really solve for, right? Oh, we can label this triangle. We can label it triangle ABC. I'm always very original with my labeling. You could be more original, that's fine. You could do triangle, I don't know, MAT, M-A-T, I don't know. Okay? Now, how do we solve for that angle A? 180 minus 75, that's 105, minus 62, that's what, 43? Okay. 43 degrees, that's the smallest angle, so that tells me this is smallest side. So that tells me when I'm solving, the lengths of the wires are going to be longer than 60, right? To the nearest tenth of the meter, how long are the wires? So how can we solve for the wire lengths now? Good. We can use the sine law. So we can say 60 over the sine of 43 is equal to side length C over the sine of 62. Can I have this half do that? Can you solve for side length C? I'm going to split the middle table right in half. You guys solve for side length C. And then this side, can you solve for side length B? You're going to use the same kind of process where you're going to have 60 over the sine of 43 is equal to B over the sine of 75. So I'll give you about a minute here to solve, and then I'll ask for help. Okay, and it said to the nearest tenth of a meter, right? Nicole, what side length did you solve for? And what did you get for C? So 77.7. Ooh, you didn't get that. What did you get? 84.9. So let's just check out what we should be doing. You did B instead of C? Okay. So then we're okay? Are you guys okay if I did 77.7? And then this is meters, right? And then side length B, what did you guys get over here for side length B? 85.0? Now, I'm going to tell you something. In math and in science, you should carry all your decimals all the way through. So like 77.67, blah, 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 and what was it, 84.97, blah, 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 blah. You should try and carry them through if you're going to use the next part. I'm very picky. Oh, Morgan knows. Okay, so what I'm going to say is probably you need to carry at least 4 or 5 decimals if you're rounding to the 10th. Okay, so we actually solved for side length C here, 77.7, and side length B is 85 here. We want to know the height of the mast. Okay. Okay. So you can choose either triangle. Okay. So the ones that solve for side length C, use all your decimals. And the ones that solve for side length B, you use the decimals on your calculator. Okay. Now, how can we solve for the height? Well, we know this angle, and we know a side length now, right? We know the hypotenuse. What is the height? Is it opposite or adjacent to an angle? It's going to be opposite for both of you, right? So opposite and hypotenuse, can you do a squared plus b squared equals c squared? No, because the bottom length is all the way 60, not just this portion is 60. You can't just divide it by 2 because it's not equal, right? It's not cut right in half, okay? So we've got to use the sine law, right? So I could use the sine of 75 degrees is equal to opposite. That's what we're trying to find out, right? The height of that mass over adjacent, no, hypotenuse. Sine is opposite over hypotenuse. So that would be the 77.67 degrees, blah, blah, blah. Use all that decimal. So how do you actually solve for the opposite side? You multiply, right? Sine is 75 times second answer, right? If for some reason you found side B last, you could do it using the sine of 62, right? Is equal to the opposite over 84.9 blah, blah, blah. Right? Either way you guys do this, you should get the same answer. So the ones that are solving it on this side should get the same height that's solving it on our other side of the classroom using the opposite triangle, okay? What height did you get, Aaron? 75. And you got 75.1? No point ones. Did you use all the decimals? Did you use all the decimals? 75.1. Oh, and then it rounds up. So let's just run through this quickly. 60 times the sine of 62 enter, divided by the sine of 43, gives us that 77.67. So if I multiply it by the sine of 75, it gives me 75.03. Okay? So let's look at the other one. 60 times the sine of 75, enter, divided by the sine of 43, enter, gives me that 84.97, right, that you guys had. And 84 times 0.97 times the sine of 62 gives me that 75.03. Okay, so either way you went about to solve for the height, you would end up with the exact same value, 75.03. Now, some of you might have had some other issues or something that I can come and check on your calculator for you. But that's it. Big thing with applications, draw a picture. Okay, if it's drawn for you in the textbook, redraw it on your assignment sheet so you actually can write all over it. Okay? Can I give your assignments? You have a question, Luke. I did it with the sine of 75 up here. I did it both ways. Right? I went through both ways to solve it. Okay. So I have 4 questions for you guys. Every single decimal. Or at least 5 or 6 for sure. But it's just as easy to hit second answer than to type it all in. Right? So your assignment is on page 126. There's 4 questions. Question 9, 10, 12, and 13. You're going to get a bell work tomorrow with an application question. If you finish early today, we're halfway through our second unit here. So I have a mid-unit review. So if you finish early today, you could work on the mid-unit review today and save you some homework tomorrow. Okay?